Hello students, this is section 5.3. It is almost a repeat of 5.2, but we are going to use technology. Essentially, we're going to use some, web pages online where we can graph all of these scatter plots and analyze and put line of best fit, that sort of stuff. There's not going to be a lot of writing that I'm going to do here in the notes. Um, but we will refer to these questions when we are actually doing the graphing. So we're going to go to a website called Desmos. So if you go and type in Desmos into Google or whatever search engine you're using, that'll bring you to here. And you're going to click on Graphing Calculator Desmos. Click on that, and it brings you here. So this is essentially a graphing program. I'm just going to close this so you can see everything. It's essentially a graphing program. You can create graphs. You can essentially solve equations and a lot of different things. So for now, we're just going to create graphs. I'm just going to shrink this a little bit. So this is what the layout of Desmos is. You can actually create an account and get a little more options, but you don't have to. It's a free service, and for everything that you need, really, you don't need to create an account. So this is the layout. You have a Cartesian plane right in the middle. You can open it up more if you click on this button up here. It just kind of puts the other column just to the side. You can bring it back up just by clicking on this button again, and it opens it up. On the right top hand side, there's a few things here. There's a little wrench, which is for settings. So if you click on it, there's a bunch of settings. I know it seems overwhelming, but there's a bunch of settings that you can adjust. You don't really have to do anything right now. I'm just going to click back on the screen. You don't really have to do anything right now. We have a plus and minus. This is just to zoom in and zoom out. You can also, if you have a wheel on your mouse, you can do the same thing here just by doing the wheel. And if you click on home, so if I zoom out and you can see this home kind of button comes back, it's just a default zoom, so it's whatever opens automatically on the window. So if you click on it, that's what it is. All right, so now we go to the left side here. This is kind of the action center. There are a few important things that you can use here. This plus button is actually what we're going to click on first. If you click on it, there's a few options. There's something called, they say, expression. Really, that's if you want to type in an equation. We are going to use that. There's a note, table, folder, image. Really, what we are interested in now is this table. So what this is going to allow you to do is you're going to be able to create a table of values. So I'm going to click on that table, and this is what you get. It says x1, y1. So this is your x-axis, y-axis. So what you can do here is you can start entering any points that you might have. So let's say, I have x's 1, 2, 3, and you can see that if you go in consecutive order, 1, 2, 3, 4, it starts actually predicting. It's not going to do that all the time, but if it's in that order, and then you can just press enter and it just keeps adding it. And then for y, you can do, I don't know, I'm going to make up some values. But for now, you can see there's nothing on the graph. Nothing's happening here, still the same graph, zoom in, zoom out, same thing. As soon as I start adding the y values, I'm going to create points, right? So let's say this is going to be 2. So as soon as I put that, now I have point 1 to 2. So here we go. This is 1 because 2 is here. So if you zoom in, there you go. See, it's 1, 2. And if I enter a y value for the second point, let's say 4, it graphs it. And so on and so on. So for, let's say, 6, 8, 10. I'm creating a linear relationship because you can see it's the same pattern. I'm just going up by 2 every time. 12, 14, and last one I'm going to mess up. I'm going to put 20. There we go. So you can see these are all straight, and then this next one, oops, it's off. And that's okay. I'm going to change it back just for the purposes of our line of best fit. So it should be 16. There we go. So that's what our scatter plot looks like. If we, did it by hand, it would not take this fast, that's for sure. We would have to create a scale and all that stuff. So this technology setup, it's really useful because it speeds up a lot of things. So line of best fit, there's no ruler around. There's no ruler. If I look around, there's no options for rulers. Oh, that's overwhelming. There's nothing here for ruler. So what we have to do in this case, in Desmos, is we kind of have to write a kind of like an equation. So where do I write that? Well, if I go under my table of values here, you can see that there's another kind of row here. It says 2, there's a third one, but I'm just going to click on this 2, and I can start entering things. I can actually, start from scratch and enter another table of values like this, but I don't need that. I'm just going to press X and delete that. There we go. So I'm going to click on 2 again, and this is what you're going to have to write. You're going to have to write Y1, and all you have to do is just press Y1, and it'll automatically put it into subscript. And then you need a squiggly line. It's this one. It's the line that's usually in the top left corner of your keyboard. I had to press Shift, and it's right above Tab for me, Tab button. But you might have to look for it in your computer or whatever device you have. And then here's the next part. M is the other one. And then you type in X1, and it automatically puts it into subscript. And oh my God, we have a line. And the last thing I'm going to do is I'm going to press plus B. There we go. And that, believe it or not, is the line of best fit. It's the most perfect line of best fit. It'll always be the same for everyone. When you do lines of best fit by hand, there's a lot of variations. My line of best fit might be a little different than yours, and in the computer though, all of them are the same. So this is our line of best fit. It looks kind of nice. We can do a few nice things here. You see how the points are green? We can change the points. So if you go here and click and hold, oops, click and hold that green part, you can change the color. So let's say I'm going to click on blue, and that's going to be my color. It's kind of nice. I can change the shape of these points. So right now it's solid. I can put it as circles. I can put it as X's. I just like the solid points. And that's it. And we can change a few different things, but we don't need to right now. You can kind of play around with it if you have the time. In terms of my line of best fit, it's green, same thing. I can turn it on and off just by clicking at it. If I press and hold, I can change to different type to dotted line or dashed or different colors, so on and so on. So there's a few variations here. In any case, this is a line of best fit. As you can see, it's going up and to the right, so there's an increasing relationship, and that's it. So that's how we're going to be able to analyze it. In terms of extrapolating and interpolating, if you remember estimating some points, super easy, because all you have to do is you have to click on the line of best fit and it gives you the points. So you can keep dragging along and extrapolate or interpolate wherever you want. So if I want to estimate a point 10, all I have to do is drag it up to point 10, and you're going to see that X is going to say 10. There you go, 10, and then the Y is 20. So you don't have to do the line up and over. So the key here is you click and hold. You have to click and hold. You can't just click on it, because if you click on it, it just disappears. So you have to click and hold, and then you drag it, and sometimes you have to be very finicky and gentle until you hit the exact value, but there it is. That's your extrapolating, or if you want to interpolate somewhere in between, you can do that as well. So that is the general function of this. If you ever want to close any of these, and I will do that right now, all you have to do is press X. So how does that translate into our application? Well, there's some examples here. You can check out the examples, but I'm going to go into practice. Here we go, practice. We have Fraser did push-ups every day for 2 weeks. He kept a record of how many he could do. So there's number of days, number of push-ups. Um, the number of push-ups will depend on the days. So days is going to be our X variable. That's the independent. Days just pass by, that's our time. So, okay, I'm going to create this table, but I'm going to put it in Desmos. So I'm going to go to here, and I'm going to click on the table. There we go. It does, see, I have the screen here, the notebook here, but I also have one in my hand. I'm just going to open it right now. Why am I doing that? Well, I don't want to keep flip-flopping between, the two screens, even though maybe that might be seem easier, but I don't know, it doesn't seem easy to me. So the good thing is he's counting days from 1, 2, 3, 4, all the way to 14. So that means when I go to my Desmos and my X1, all I have to do is press 1, enter, 2, enter, and it's already starting to predict. So all I have to do now is just press enter all the way to 14. There we go. So my X is already created. The next ones, I am entering the press number and then enter. So first one is 3, 3 again, 5, 7, 7, 9, 12, 15, 19, 21, 24, 28, 29, and 32. So as you can see, it was creating points all the way through. Um, as I was typing it in, it was creating the points automatically. So that's how fast it is. Here's our graph, scatter plot. Beautiful. So let me just go back to, this says create a scatter plot using data, using technology. Well, we did it. Done. Move on to the next part. It says develop hypothesis about a potential relationship between day and number of push-ups. So this is where we're analyzing the graph. We can see, okay, it's going up and to the right, which means that there's an increasing relationship. As the more days this person does push-ups, who is it, Fraser, the more push-ups they'll be able to do. So essentially, the more they exercise, the fitter they are, the more push-ups they can do. So that is going to be our relationships in this case. Oops, don't need that. This is one. And that's what you write here. So yes, let's write it. I guess I just have to grab my pen. Let's see how this is going to work. Um, Here we go. Just give me some time. I wanted to say it, but I forgot. If at any point you guys want to stop, the recording, do all this graphing, you can totally do that. So, hypothesis, um, the more days, what's his name again? Fraser. The more days Fraser does push-ups, the more push-ups he performs. There we go. That's our hypothesis. Hypothesis, maybe, I don't know, maybe you've heard it in science. A hypothesis is essentially a prediction. Can we predict what's happening? Well, I think we can just by looking at the points. So the next part says use linear regression. Linear regression just means find the line of best fit. So I'm going to go back to Desmos. Remember what we have to punch in. So here it is. I press on this one. I will press Y1. The reason why I'm pressing Y1 is if you look at the table, this is my Y1. I'm not going to press Y2 because, this is not Y2. If I put Y2, it's not going to work. So that's why I press Y1, then that squiggly line, and then MX1 plus B. And there we go. That's my line of best fit. So if I go back to this, use linear regression to draw a line of best fit, check, I'm done. And then it says estimate the number of push-ups he will be able to do on day 20. All right, super easy. I click on my line of best fit and start just dragging it up to day 20. Let's see, 20. Okay, there we go, 20. So it says 45.286. Okay. What does that mean? Can you do 45.286 push-ups? No, really. We're gonna just talk about, full push-ups. It's either 45 or 46. So because it's not fully 46 push-ups, we're gonna say that on day 20, he should be able to do just 45 push-ups. So on day 20, Fraser will do 45 push-ups. So because this is a real life situation and you have kind of a whole push-up, there's no half push-ups, we have to round it. In this case, we're rounding down. All right. So that's kind of it, how you use Desmos to analyze things. Instead of graphing by hand, it's much faster, cleaner, and it does a lot of work for you. So this is the strengths and weaknesses. Weaknesses is that you might not have this computer with you at all times, or a phone or whatever. By the way, I think there's an app for the phone as well if you want to use it on your phone. All right, so next one, it says create a hypothesis for each. Okay, so we're going to skip this one because I do want to just use more of an application thing. Okay, so there we go. So here we have another situation. Miguel did some research on a minimum wage for an adult in Ontario and found these facts. So this is a weird table of values. You probably never seen one of these. The reason why it has like 4 rows, you might notice that there's year minimum wage, year minimum wage. This is actually a single table of values, but instead of going to the right, they kind of ran out of space, so they kind of just continued down here. And you can see that in years. It goes from 1986 to 1994, and then skips down, starts in 1995, and so on and so on. So really, this is a single table of values. If you want, well, we will have to create a single table of values when you do it in Desmos. And so we're going to go and do that now, and then we're going to analyze it. So we're going to go to Desmos. I have this old graph. I'm just going to close it, close all of this. I'm going to go to the X and press the table. So it's again X1. If I create another table, this is where X2 comes in. So see, it has X2. So this is a different table, so it gives it a different subscript. But I'm using this one. So it starts, again, I'm using the workbook because I don't want to flip-flop back and forth. Let's see. So I have 1986. The problem here is computer's not going to predict the next year. 1987. I'm pretty sure, unless they updated it. Oh, did that just do that? Yeah, it did. Okay, so you have to be careful that sometimes years are skipped. So next one is 1989. Good. 1990, 1991, 92. Okay, so they skipped 93. Ugh, that sucks. So we'll have to change this. So 1994, and then 1995, 2004. So yeah, sometimes if they're not in consecutive order, you will have to enter it just like I'm doing right now, and you will be doing it as well. I'll just take some time. It is still faster than actually doing it by hand. And 2010. There we go. And then I'm going to go back and I'm going to enter all the y-axis. Now, you might see that I will enter 4.35, and you will notice, oops, 4.35, now 4.5, and you will notice there is no point. The reason why there's no point is because our x values are 1986, and right here on the screen it goes up to 60, so I have to zoom out big time. And you can use this button as well, but I am zooming out with my wheel, and you can see there's a point here. It's 1986, 4.35, super small. So I mean, you'll just have to zoom out and kind of search for them. Next one is 4.55, 4.75, 4.00 is just going to turn into 5, 5.40. There we go. 6.85, 7.14, 7.45, 7.75, 8. Oops, I pressed 9. 8, 8.75, 9.5, and 10.25. So I just entered this. This is my last point. Sometimes you will run into a problem and you will notice that you finish all the y values and there's an empty spot. That just means you should go back. You might have skipped a number. In any case, I entered all the points and I'm not seeing much here. So what I have to do is I have to zoom in. So I put my mouse and I'm just wheeling. I use my wheel and there we go. Now we're seeing these points. And you can see there's this weird, there's like an increase, giant gap, and then there's another increase. So I'm going back and I'm looking at, okay, so here's the question. Here's the question. It says, develop a hypothesis about whether there's a relationship between data. So the hypothesis is usually done before you graph it. I didn't develop a hypothesis. We could assume that the minimum wage is going up in Ontario, and yes, that's been confirmed by our graph. Yes, it's going up. But that would be my hypothesis in the beginning before I would graph it. But I was just too eager to graph it and use the technology. Anyways, we made a scatter plot. Was my hypothesis correct? Well, yes, I did it after, so definitely would be correct. But how would I analyze it? If I look at this graph again, it seems like there's a giant gap. So what happened during this minimum wage time? So there's a few reasons why that might have happened. Maybe they stopped tracking it, or I don't know. They probably stopped tracking it because it seems like the minimum wage is pretty close for like almost 10 years. That's not really the best thing for in terms of wages. It's kind of frozen, so it's not a good thing. If we wanted to do a line of best fit, I could. I'm just gonna scroll down and click here. Remember, Y1, squiggly line, MX1 plus B. There we go. That would be my line of best fit. It looks a little weird if you zoom out. Very strange. Why is it strange? Because it actually goes down at in 1961. It's at zero, which means that you were working for free if that was the minimum wage. But really, that's not the case. In this case, the line of best fit might not be the best thing to use for extrapolating, more for interpolating maybe, but as soon as you extrapolate, extrapolation is not as accurate as interpolation, so we don't use it, well, we don't count it as super accurate. So that would answer that question. So if we go back, is there another one? Yes, there is. So mail in, let me just see how big is this question. This is good. Okay, and there's chapter review. So yeah, let's do it. Let's see how we are on time. 23 minutes. Actually, you know what? I'm going to stop it here because the first video was really long. This one and the second one was, fairly decent size. So we're going to stop it here. If you want to check out this question number 5, Maylin, just follow the same process. It's not more than different than what we did. Really, it's just using kind of Desmos. I do have actually, if I go, I'll show you on my website. There we go, Merrimack Math. And if you go to courses, what is this? Skills. Nope. Is that the one? Oh no, there we go. On the top, courses, Desmos resources. So if you click on there, there's a bunch of videos on how to use Desmos more. So you can check this out and you should be okay. That's it. Thank you very much. Bye.